all of our meetups and put them online. And I want to say a huge thank you for Roman and Mike, who's doing a tremendous job doing all these things. Huge round of applause. It's extremely time consuming. We also have a Slack channel. So for those of you who haven't heard about that, it's a Slack channel for all the front-end JavaScript stuff in New York. All the meetups are there: React, Angular, and Vue, TypeScript, a bunch of other things. So join and raise your hand if you are here for the first time. Somewhere in late April, probably last week of April.
No video. I could just start talking. Yeah, there's no. Woo! Yay! Cool. I figured I'd start with an XKCD slide just because those make people happy. The biggest point of this, today we're going to talk about functional programming fundamentals. The main reason I like to pull this up is because none of this is new. These are all very old concepts that have just become popular again in recent history, and we're going to talk about those a little bit. So my name is Matthew. I am an engineer at Dropbox. You can find me on the Twitters. You can also look at these slides on Bitly if you want to refer back to them later. And like everyone else, we are, of course, hiring. So if you're interested in that, come talk to me. So what are we going to talk about today? We're going to talk about functional programming, and we're going to talk about declarative versus imperative styles. You probably hear a lot about declarative programming with React, and we're going to take a step back to the fundamentals. What are we not going to talk about today? We're not going to talk about monads. We're not going to talk about lambda calculus. We're not going to talk about functors, and I am going to avoid as much scary technical jargon as possible. And the reason for that is I think it gives FP a bad rap. This XKCD says functional programming combines the flexibility and power of abstract mathematics with the intuitive clarity of abstract mathematics. Right, like it should not be this complicated. We're just going to go talk about something that's going to make your code better. So yeah, this is the Wikipedia page for lambda calculus. I don't know what it means. So Taylor says this is absurd. I agree with her. So let's take a step back. I believe in two things. One, you should use the best tool for the job. And two, much like the ice cream emoji, moderation is key. So we're going to shake it off, and we're going to get to the point. So the point of all this is we want to make our code more readable. We want to make it easier to reason about. We want to make our code easier to test. And then we want to make our users happier. Like that's really the goal here. It's not to like write the coolest thing. It's to write the best thing and make our lives easier. So when is functional programming most useful? So this is a React meetup, so I'm going to tie it back to React and Redux. Functional programming is extremely good at doing one-to-one data transformations. So if you look at a React application and you've got your Redux store in the back and you've got React in the front end, you've got Lodash or Lambda or whatever library you want in the middle, that's your functional selector layer. So that takes the way you store it in users, and it'll work the exact same way every time. So side effects are the real key to what makes something not a side effect. And again, I'm not here to say that all side effects are bad. They just mean that they're not a pure function. So a very simple example of a side effect is mutation. So in this case, we have a pop function that takes an array and pulls off the first element of it and returns it. And this array has now been changed, so it's a little harder to reason about what's going to happen if we call this function repeatedly on different arguments. Shared state is another one. Now we have these increment and decrement functions, and if you randomly call these in different orders, you don't know what I is going to be. If someone goes and sets I to be a string somewhere, that's just going to break your application. And you really want to have some guardrails around this. really know what its value is at any given point in time. And that's okay, this is the web, but again, just in the context. So, my last Swift tip. I would very much like to be Swift in this narrative. Don't worry, we're going to move on to the So, look at an example. Themes. It's actually going to be this, which is probably not what you expected. And the reason for that is that the two functions in the middle were operating on the same reference, and then fun fact, I threw a bug in there, add scar doesn't return anything. So while you probably expected Harry with no parents, and Harry with no parents and a scar, it's actually much harder to reason about, and that's what makes pure functions a lot nicer. So I'm going to pause for a minute and move on to declarative and imperative. Now, I couldn't come up with a GIF for this, so I said, why not Zoidberg? So I will just let you enjoy him sucking on a turkey. That's really it. It's completely unrelated. Declarative code describes what it does. Imperative code describes how it does it. So with React, we don't care if it's been incremented or decremented or where it's stored. All we know is that I call this function and it's a pure function. And it's going to have to do all this extra processing. And I'm not sitting here saying, or standing here saying, that imperative code is bad. There's totally a place for it. And then did you know that there's actually faster ways to do for loops in JavaScript? You can start at -1 and then combine your incrementer and your exit clause, which you should never ever do in your code that other people have to maintain, but let the library do it. In fact, that's what Lodash does under the hood. And it doesn't have to be Lodash, it could be Ramda, it could be immutable. If you are into mootools, whatever. But anyway, you call Lodash.keyBy, it does the exact same thing. Another very similar example is get file names. So we have a list of files, and we want to grab a single property off of all of them. And this is actually just a map, which is now in ES6. You don't even need Lodash. And it's just Lodash.map files, and then you get this one property off of all of them, and it spits out a brand new array. And we can trust that this thing works. We can trust that it'll be as performant as possible. And it's keeping our code a lot easier to reason about for our developers who are working on it. So now we're going to talk about some more advanced functional concepts. And this is Harry getting his wand. We're sticking with the Harry Potter theme for a little bit. Bear with me. It makes me happy. The first one is separation, which I'm going to pair with composition. So if you try to perform effects and logic at the same time, you may create hidden side effects, which cause bugs in that logic. You want to keep functions small, and you want to do one thing at a time and do it well, which pairs with another concept nicely called composition, which is that you should plan for composition. You should write functions whose outputs will naturally work as inputs to many other functions and keep function signatures as simple as possible. So let's look at an example to make this a little easier to understand. So I have all these little one-liners here. I have sort files by name, which is lodash.sortby. I have get PDF files, which filter is a functional concept where it says only include the things that are truthy for this clause, which in this case the extension is PDF. And the final function is get file names, which we've already discussed. And these combine really nicely to create a combined function. So Lodash and many other libraries provide something like flow, which allows you to combine these functions into one super function. So if you're comfortable with a terminal, this is very similar to like a bash pipe in that the new function will get the arguments that is passed to it, and then it will pass its output to the next function. So we will go through the list, we'll get all the PDF files, which shortens the list, then we'll get the file names, and then actually we can just give it lodash.sortBy as a function because it's now just a dumb array of strings. Now, I've included an alternative here, which may or may not be more readable to you, and this is functionally equivalent. Now, Lodash will do some optimization under the hood, and most libraries will when it's combining these things, but I really just wanted to be able to illustrate, like this is just call a thing inside, call it in another one, and keep passing these function calls. It's just two different ways to look at the same concept. So because we've made all these functions separate, they easily compose. So the next concept is immutability. The true constant is change. Mutation, hide, sorting, or things that might be a little expensive, if you know it's the exact same list, you can just memoize on it. So I've done another example, and the first function is called kill sibling and takes a wizard. Yeah, it gets dark now. And you'll notice we're using the spread operator to copy over the wizard, and then we're decrementing the number of siblings the wizard has. And I know this could theoretically go less than 0, but let's just assume it's not going to. And the first thing I'm going to do is I'm going to memoize this kill sibling function because we don't want to forget it. And we're going to pass it Ron Weasley. So yeah, it was a sad book. So we call kill sibling memoized on Ron, and that generates a brand new object, which is Ron after Fred dies. And if we compare those two objects, he's lost his brother. He's a different person now. Like, he's not the same. And that makes things really easy for us to reason about. This is actually how Redux and pure components work under the hood, in that they're just saying, hey, something has changed, which means downstream, go figure out if you need to re-render or not. And that's why those should component updates in the middle of your React tree are useful, because you can just check, hey, did a reference change? No, then I know nothing's changed and we're good. And that's the nice thing about memoizing, is it can memoize on the reference to the object. So if I call kill sibling memoized on Ron, and then it's Ron after Fred dies again, it's going to return the exact same object. Now it's worth noting that if I didn't memoize this and I just called the original kill sibling, I called this one Ron after movie Fred dies because the movies are not as good as the books. And if we compare those two, they are not equal because this kill sibling function is always returning a new object. So it's a little bit of a gotcha there, but as long as you're paying attention, you should be able to use this to optimize your code. So next, Hermione Granger. Should check this out for a bit of light reading. The next thing we're going to talk about is higher order functions. Now you might be familiar with higher order components, which have now fallen out of popularity to render props, but these actually come back to an older concept called higher order functions, which are simply a function that does one of two things. It's a function that takes a function as one of its arguments, or returns a function as a result, or both. And you've probably done this a million times without knowing the term higher order function. So a great example is a function that takes a function. So we have this promise fetch, which returns a promise, and then has the then callback. Then is a function which takes a function, which is your callback. So a function that takes a function is just a callback and happens to be a higher order function. Another example is a function that returns a function, which is a closure. And you've probably made these before too. So I have this function called counterGenerator, which returns a function that is going to increment I and is going to log a different value every time. Now, an interesting thing to point out is counterGenerator is a pure function because it's always going to return a function, whereas the internal function is not because it has some type of internal state. And that doesn't mean there's anything wrong with it. It just means it's not a pure function, and we should remember that when doing data transformations or whatever else we might be doing. So the last one is a function that takes a function and returns a function, which is just a wrapper function. So memoize was a wrapper function that returned a new function. Debounce is another really cool one, which just says fire this thing when the user has stopped doing it. So like if I put a debounce on a scroll handler, it'll fire it when the user has stopped scrolling. This is really commonly used for like type aheads or for like hitting a server. And function that takes a function and returns a function, doesn't that sound a lot like function that takes a component and returns a component. It's a higher order. That's how higher order components work. Last scary concept, I promise, and Ron Weasley agrees with you that this is not light. So currying and partial application. And these are really cool and can make you do nifty things with your code. And I want to point out that Redux in particular leverages currying like crazy. If you've ever seen the middleware layer where it's like next, action, dispatch, that whole thing, that's currying. And we'll get to that in a second. So currying is a technique of translating a function into a new function that can take any number of its arguments and will return a new function until it's done receiving all of its arguments. I know that sounds like a mind bend, so let's just look at an example and it'll make a ton of sense. So I have a sum function which adds a, b, and c, and if I curry it, I can pass it all 3 parameters and it returns 6, which is what you expect. If I give it only the first 2 parameters, then it creates a new function which is waiting for the 3rd parameter, which is called add5, and I can just pass it a 3rd parameter. Or I can only pass it 1, and now it's a function that's waiting for 1 or 2 parameters. So this gets really useful and is commonly used just like in the depths of the libraries you're using every day, so it's worth knowing about. Now this last subject is called partial application, which is similar. And I know I've promised no technical jargon, but arity is a simple one, so I'll just tell you what it means. Arity is a term for the number of arguments a function takes. So if a function takes 1 argument, its arity is 1. If it takes 2, its arity is 2, 3, and so forth. And we just talk about reducing arity because that makes functions easier to compose and easier to flow into each other and easier to memorize. So partial application is the process of fixing an argument to a function to reduce its arity. And I have another example for you involving more wizards. This one is less dark. So this wizard wants to learn a spell, and it's immutable. We copy over the wizard, and we copy over all the spells that the wizard knew. And you might notice this looks a lot like your return in Redux, probably. And I've created learn Expelliarmus, which is just using _partial to bind the string Expelliarmus to the first parameter. And I've done the same thing with expectopatronum. So now we have Harry Potter, and in the second book, he learns Expelliarmus, and it creates a brand new object that has Expelliarmus in the spells. And then we pass it to learn expectopatronum, and it creates a brand new object that has both of the spells in there. And while partial application might seem complex, we've actually seen this already tonight. So throwback to 10 minutes ago, all these functions are examples of partial application. So sort files by name, we are binding the right parameter, which is name, to this function. And now we have a function that has an arity of 1 and is easier to compose like you saw 10, 15 minutes ago. And the same thing for get PDF files and get file names. This is actually functionally equivalent to doing partial write, which just says partially apply from the right side as opposed to the left side. And it'll produce these brand new functions. Now again, I want to call out to readability and tell you that neither one of these is necessarily better. If you have a library doing partial application, it will be minusculely more performant than the first one. But if you're working with 200 other engineers and none of them are going to understand that, and that's going to go introduce new bugs, maybe you shouldn't do it. So let's take a step back again and remember why we're doing all this. We want to make our code more readable. We want to make our code easier to reason about. We want to make our code easier to test, and we want to make our users happier. That is the goal. The goal is not to reduce the number of lines of code. We're not playing golf and trying to get the lowest score possible. My friend right there is mad at me because he loves code golf. So just some other resources I want to call out to, aside from these slides. There's an amazing book called Functional Like JS that takes this to the next level, which talks about using functional programming but not going over the top. There's a great talk called Hey Underscore, You're Doing It Wrong from a couple years ago that talks about how underscore wasn't quite functional. That one's from 2014. And actually, that one's from like 2012. And then John David Dalton, who is the author of Lodash, gave a talk on unorthodox performance, which talks about the crazy imperative voodoo he does, which makes it much, much more performant than you writing for loops on your own. So those are 3 cool talks that you could watch or read. And now we might have time for questions.
Yeah, let's take 2.
Yeah, so the question was just why didn't I mention immutable JS? Yeah, so immutable JS is a fantastic library. You can totally use it. The reason I used Lodash is because that's what we happen to use at Dropbox. Immutable JS is a little newer, and there's no reason you shouldn't use it. There are a lot of FP libraries out there, so I would just recommend reading them and picking the one you want. You're right, there was a little extra boilerplate here, but that was mostly to explain the fundamentals and not necessarily something that may or may not make it into production. It's a good question.
You mentioned that functional programming concepts are very old, that are only now coming into vogue. I'm just curious if you have an idea of whether or not like functional programming is here to stay, or the thing like it's going to wax and wane the same way it has historically.
So the question was that I mentioned earlier that functional programming has come back into vogue, but these are very old concepts, and whether or not I think it's here to stay. And the honest answer to that is everything goes in and out of fashion, whether it is code or JavaScript framework, or if you've noticed, over 20-year periods, jeans get skinnier and baggier, just so that way we have to all throw out our jeans. So everything goes in and out of style. 10 years ago, everyone was doing OOP, and in 10 years, they might be doing it again. What I can say is that these are generally good concepts, and that if you don't over-apply them, they can help. But the answer is, I don't know. React might fall out of style. Redux might fall out of style. It's really... I didn't say it will, I said it might. There was a great tweet a couple weeks ago that said, I just got out of a React thought leader meeting. We all hate Redux now. Go rewrite your code. So it's like everything falls in and out of style. I think the core concepts are really worth learning about, though. So I have one more XKCD comic, which makes fun of functional programming, which is that the problem with Haskell is that it's built on lazy evaluation, and nobody's actually called for it. And my name is Matthew Gersman. You can find me on Twitter, and you can see these slides at the bit.ly link. Thank you so much.